the way this rim needs to go. To move the rim relative to the hub, we use changes in spoke tension from one flange. The spokes in the rim are coming from the left and right flanges. Each side is pulling the rim toward their own flange. Tightening only spokes from the right flange moves the rim to the right. Tightening only the left side spokes moves the rim toward the left. However, because the rim has tension from both left and right side spokes, we can also loosen to make corrections to centering. Loosening only the left side spokes also moves the rim to the right because the right side tension will pull it over. Loosening only right side spokes will move the rim to the left. Keep in mind that tightening one side raises the overall wheel tension, even of the side you're not tightening. For example, tightening the right side moves the rim to the right, but it also raises the overall spoke tension, even of the left side spokes. This is when it's a good idea to get a sense of where the wheel's at for tension. With enough experience, you can squeeze and get a sense of this, but this is why we'd recommend a tensiometer like the TM1. Here, check a few spokes. This wheel we're looking at is pretty low tension. Tightening the right side of this wheel to fix the dish would be a good choice. It will fix the centering error and raise the overall tension. On wheels where the flanges of the hub are different to the center of the hub, such as rear wheel with sprockets, or on front wheels with the rotor disc, you're going to see differences of left and right side spoke tension. The side that is inset or further in is going to have higher tension. You can measure it and even feel it on these wheels. This side, for example, feels tight, but squeezing the non-drive side feels looser. That's simply the engineering of these wheels and is a normal thing. And this is why we pay attention to the tightness of the inset side, the tighter side. The other side will simply be lower when the dish or the centering is properly set. When available, install the wheel into a touring stand with the right side on your right as you face the stand. This helps you orient yourself to the wheel so you can remember which way the rim needs to move. Adjust the caliper indicators out of the way. The dishing tool has already provided the most accurate information on which way to move the rim. This particular wheel has an air seen at the left side of the hub. The rim needs to move to the right. Use the tire valve hole as an easy, recognizable starting and stopping point. Select a spoke from the right flange that is adjacent to the valve. When just learning to make dish corrections, it is best to work in small increments. Install the spoke wrench fully on the nipple and take note of the wrench orientation. Turn the wrench 1/4, which is turning the wrench 90 degrees. Seen from looking over the nipple, this is the way you will tighten. After turning this first right side spoke nipple 1/4 turn, advance to the next same side spoke and again tighten 1/4. Continue this way all the way around the rim, tightening only right side spokes until you are back to the starting point at the valve hole. It is common for the wheel to develop some minor lateral chewing issues from this change in tension. Spin the wheel and correct any lateral error. Because the rim is moved relative to the hub, you need to reset the dishing tool starting again from the right side. We want to see an improvement and a reduction in the air gap. If the air is still too large, it may take several attempts to get the rim centered. This gap is smaller, so it's getting better. Repeat the correction, again using 1/4 turn. Check the dish reference from both sides and repeat as necessary until the wheel shows 1 millimeter or less gap at the hub. In this rear wheel, we found that the rim needs to move toward the non-drive side. On a rear wheel, a concern for maximum tension is the flatter side, the drive side that's inset more. A check of this side shows this wheel is actually very tight tension. Although we could fix the centering by tightening the left, it's going to rocket the tension beyond where we want. So in this case, we would loosen the right side, help back down the tension, and correct the dish. Loosen the right, check the lateral, check the dish until it's in tolerance. Begin at the valve hole and loosen each drive side spoke 1/4 turn. Check the lateral true and check the dish. On a wheel like this one that has good overall tension, but bad dish air, it makes sense to make corrections to both sides. However, don't do your tightening and loosening in one pass. First, loosen the side that needs loosening, correct lateral air. Next, tighten the side that needs tightening. Again, check lateral air. Finish by checking the dish and see if it gets within tolerance. And that's how we check wheel centering and how we correct wheel centering to get the rims in the middle of the bike, the frame and the fork for the best handling possible.